Hey, welcome back to the tutorial. Okay, in this lecture, let's download the FreeRTOS and let's explore its contents. So let's go to the freertos.org, click this link to download the source code, then click on this link. Click to download the latest official release from SourceForge. The code is basically hosted in sourceforge.net. You'll be directed to sourceforge.net. Okay, now the download has started. After downloading, you need to install this and later you will have this folder. So this is FreeRTOS version 9. So this is the latest version of FreeRTOS which is available. Once you open this folder, you will see there are two subfolders and a README file. Let's open the README file. It says FreeRTOS/source contains the FreeRTOS real-time kernel source code. FreeRTOS/demo contains a free configured demo project for every official FreeRTOS port. First, let's check out this folder FreeRTOS. Alright, this folder has three subfolders: demo, license, and source. The source folder is the one which contains the source code of FreeRTOS real-time kernel. Remember that the kernel is implemented by just these 5 files. That's it. So these are the kernel files. All your FreeRTOS features like scheduling, task management, queue management, semaphores, timer services, everything is implemented by using these 5 files. And this include folder has all the supporting header files. The main header file is freertos.h. The header file contains all FreeRTOS related configurations. And remember that this is the master configuration file for the FreeRTOS kernel. So all kernel specific source code will have to include this header file. Look at this feature. All kernel specific source code will have to include this header file. For example, let's open q.c. You can see the first header file you will encounter is freertos.h. Let's open list.c. Here also you can see freertos.h is included. So every source file will include this master header file, that is freertos.h. Now freertos.h will include all these header files, in which freertos config.h is very important. FreeRTOS config.h will contain your application specific customization details. Remember that this FreeRTOS config.h will not be given by freertos.org. This file you have to create yourself and with a macro suggested by freertos.org. Check out this link. This article talks about customization. FreeRTOS is customized using a configuration file called freertos config.h. Every FreeRTOS application must have a FreeRTOS config.h header file in its preprocessor include path. FreeRTOS config.h tailors the RTOS kernel to the application being built. It is therefore specific to the application, not to the RTOS, and should be located in an application directory, not in one of the RTOS kernel source code directories. And these are the macros you can use inside the FreeRTOS config.h to tune the RTOS. For example, if you want to use mutex, then set this to 1 rather than 0. Otherwise, mutex feature will be compiled out when you start compiling the FreeRTOS source code. Please don't worry about all these details right now. For every application, we will use this, and I will explain you most of these config macros later while coding. But for a time being, just remember that FreeRTOS config.h is used by every application to fine-tune the FreeRTOS kernel. Great, let's move ahead. So we are here in the source folder, isn't it? So these are our source files and these are related header files. And there is one more folder called portable. Let's open it. Great. This also has one readme file. Let's open it and read few lines. Alright, it says each real-time kernel port consists of 3 files that contains the core kernel components and are common to every port, and 1 or more files that are specific to a particular microcontroller and or compiler. Okay, it is little hard to understand. Let's forget it, don't worry. Let's read the next statement. The FreeRTOS /source /portable /memmanage directory contains the 5 sample memory allocators as described on this link. Here, let's forget all these folders for a time being and just open this folder. This folder contains 5 different heap management source files. All these are different heap management techniques. Heap_1 implements very easy way of handling heap, may not be that efficient. Heap 2 may be little more complex but more efficient, and so on. So what they're basically saying is that FreeRTOS.org is giving you 5 different types of heap memory management techniques in these 5 different source files. So you have to use whichever suits to your application. So you have to read memory management documentations provided by FreeRTOS to know more about these implementations. So without reading the documentation, you cannot know what's going on inside these files. Let's open this link which takes you to the memory management article. And here they have explained what each file does or how it is implemented to handle the heap memory. For a time being, let's not get into that because we have a dedicated lectures for it later in the course to understand the FreeRTOS memory management techniques. And of course, it is too early to explore those details. So let's move ahead. Alright, let's move further and explore other directories. The portable folder contains the processor or architecture specific codes. That means you know that FreeRTOS runs on huge number of architecture like ARM, Atmel, MSC430, PIC, etc. And on each architecture there are thousands of different microcontrollers are made by different vendors. So each architecture or MCU will have a small amount of architecture specific RTOS code that they call as port.c. So to port FreeRTOS on say ARM Cortex M3 specific MCU, this port.c is needed. That's why there is a separate folder that is this portable where all architecture specific code is stored. For example, let's open IAR and here let's open CM3. Here you can see this is the compiler used, that is IAR, to compile the architecture specific RTOS code for CM3 architecture by taking this code, that is port.c. If you open this file, you can see this is the code related to Cortex M3 architecture. And you can see IAR includes its own header file here. If you are a little confused about all this, don't worry. Just remember this. Each supported processor architecture requires a small amount of architecture specific RTOS code. So all this architecture specific code is put under portable / the compiler / architecture folder, where the compiler is the compiler used to compile that port and architecture is the architecture on which that port runs. Let's see an example. Let's say you use LPC 2000 MCU with IAR compiler. Then you will find LPC 2000 architecture or MCU specific code that is port.c in the folder FreeRTOS /source /portable /IAR /LPC 2000. So to conclude this, source has the core FreeRTOS kernel files. The include directory consists of the core FreeRTOS kernel header files. Portable consists of processor specific code. Under this, compiler X, which consists of all the ports created by compiler X, compiler Y, which contains all the ports created by compiler Y. Memory management folder contains the sample heap implementations. Now let's move further. Let's come back to our main directory. The license folder contains the license documentation of the FreeRTOS project. The demo folder will have all demo applications related to specific microcontroller and IDE. So these are the various demo applications which comes with FreeRTOS. You can find one which suits to your microcontroller. For example, if you are using say MSP432 Launchpad using Keel, then go ahead and run this project, and without any change you can compile and download the project. Great. So we explored all the details of the FreeRTOS directory structure. And let's come back, and there is another folder called FreeRTOS Plus. The README says that FreeRTOS Plus contains additional FreeRTOS components and third-party complementary products. So this folder basically contains additional software supports like TCP/IP support, UDP support, CLI support. CLI stands for command line interface, etc. So remember that this folder doesn't contain any kernel specific codes, but only third-party other software components. Great. So to conclude everything, FreeRTOS folder has three main subfolders: demo, license, and source. Source contains all the kernel specific source files and include files. Inside the source file, there is a folder called portable, which contains architecture specific code for a specific compiler, and also different heap management code in the memory management folder. License folder has one file which describes the FreeRTOS licensing, that is general purpose GNU license. And demo folder consists of demo application for specific compiler and MCU combination. And there is one more folder called FreeRTOS Plus that contains the additional third-party software components like TCP/IP stack, command line interface, UDP, etc.